It's my great pleasure to welcome you to the first plenary of EC'23 and to present Rachel Kranton. She's the James B. Duke Professor at Duke University. She was talking about networks and people being connected to one another and network models of markets before anyone else ever thought that there were such things. And so delighted to have here today to tell us about information markets and social connectedness. Rachel.
Thanks very much. So the first thing I'd like to do is thank Larry and Jason and Malesh for putting together this incredible conference. Thank you so much for all of your work. And so let's give them a round of applause to start us all off. Thank you very much. So I'm absolutely delighted to be here. I'm looking forward to the next few days. So I'm speaking to you about information markets and social connectedness, and this is joint work with my colleague at Duke, David McAdams. So let me give you a sense of what I'm talking about, and many of you have written in this area as well. So I'm trying to understand contemporary connected information markets. And some of these examples are obviously the news media, which will be my running example throughout the talk, but it can also be social influencers, or even we are socially connected information markets. We're producing information, we're trying to disseminate our work, we hope people read it and spread it and so on. So here's something I pulled from the New York Times yesterday. So consumers, to give us, just to fix ideas, this is a news article. This is an influencer. She's got some gazillion numbers of followers. So consumers share stories. So you can see that here, right? So consumers have the opportunity to share stories, and of course this is, Twitter. So consumers share the stories. They produce stories, and consumers share the stories. But producers are earning revenues from these stories, right? And so take a look at this. This is the banner on the top of the New York Times article, right? So the New York Times is earning revenue from the stories that are then being shared, and they're getting advertising revenue. And the basic question we're trying to ask here is, what is the impact of consumers' sharing behavior on producers' incentives, in particular producers' incentives to produce quality information? So we're going to eventually get to an equilibrium in the market for information where the equilibrium is the quality. We're going to try and understand the quality. So we're going to have two sides of the market, not just the consumers. We're going to have the consumers feedback into the producers feedback into the consumers, and understand how this phenomenon of consumers sharing information feeds back into producers' incentives, and think about overall information quality. So what I want to try and do in this talk is to present to you this model of the basic forces of socially connected information markets. And everyone in the room, we all have experience with these markets. You're going to look at my model and say, oh, but there's this, and oh, but there's that, and oh, but there's this other thing. And it's true, right? That what we're trying to do is give a stripped-down model of the basic forces, upon which we can then add, and I'll get to this in the conclusion, understanding things like subscriptions for newspapers as opposed to just open access news. So we're going to build a model of the basic forces of socially connected information markets, which we then hope is useful for the study of institutions, industrial organization, and policies, which are out there now. I also want to give a sense of how we've simplified aspects of the consumer sharing side. So whenever we make modeling choices, whenever we write down a model, we have choices to make, where to simplify, where to keep the complexity, and so on. So I want to give you a sense of where we've decided to simplify so that we can bring in the producer side. There's many, many, many studies of consumer behavior or sharing behavior, diffusion of information, et cetera. Wonderful work on the study of diffusion of information in social networks, et cetera. We've simplified that, try to get, again, the basic forces that can then feed back to producers' incentives. So you can all tell me whether we did it right or whether there would be a better way to do it, but that's what we've done, and I give a sense of that. With this model, I should have said, so one of the things we want to do here then is we're endogenizing information quality, And we hope the model can not only help us understand things like subscription services or industrial organization, but perhaps can help us understand the impact of misinformation. So our characters in our play here are the producers and the consumers, and the producers here are bona fide consumers, the New York Times, et cetera, or HODA. But there's also misinformation providers. So there's this very sort of scary example about the Denver Guardian, which is absolutely not a newspaper, but was published news and actually had impact on people's behavior. So now we're going to ask, what is the impact of such third parties in our market? Okay, again, with this model, we hope we can do something like that. So my plan for today is to give you a brief overview of the model of the results and then jump right into the modeling. So with this audience, I don't think I need to do too much preliminaries, even though I've already done a lot, is go to the modeling relatively quickly. But I will do the tradition in economics of at least giving a little overview and a little preview of the results and then get right to the modeling. So that's the plan. All right, so here's the overview part. So first, we're going to have a simple model of information demand. There are consumers who value high-quality information, perhaps to guide their actions to purchase a product or to perhaps to vote. Consumers tune into the broadcasts of information, and they evaluate this, we're going to call it a story. So they read a story, and they're going to evaluate that story. And they possibly share the stories, and consumers follow other consumers. So if I share a story to my mother reads the story that I share with her. So there will be network effects. We have an extraordinarily simple network, as you'll see. So what the consumers are doing here, the function of the network, is the network filters the news. So the first people that read the story decide whether or not to pass it on, but then it also spreads the news. So there's filtering and then sharing. And those are the two forces that we're building that, of the consumer side of the market, is the filtering and the spreading. So if we had information whose quality was fixed, this filtering and then spreading, the filter would filter out some of the bad information, not perfectly so, and then spread this information. Then these links, a very big network would be very good because it's both filtering and spreading the information. However, the information quality is not fixed. It's endogenous, and that's the innovation of the work, is that what spreads through this network is endogenous. The producers of whatever it is that's spreading through the network are going to have incentives to produce something that's profit maximizing, again, depending on how the consumers are then filtering and spreading it. So the information quality is not endogenous, so we build a simple model of information supply. Information supply, we're going to have profit maximizing producers. They produce high or low quality stories. They incur a cost, obviously, to have a higher quality story. What we think of that is, for example, for a news reporter, it's a verification source. The news reporter has to go verify all of the sources, for example. So you incur a cost for a high quality piece of story. The producers earn revenues from consumers who view the story. So, for example, the advertising that accompanies the news article. So this is a little bit like whoever, it's eyeballs. Producers of stories are earning revenues from eyeballs on their stories. And we then, with the combination of the consumer side and the producer side, we're going to endogenize the quality of product that diffuses through the socially connected network. And again, we feel that this is the innovation of the work. So what are the results, or summary of the results? First, that quality is non-monotonic in consumer connectedness. So with no connectedness, you're not going to get any quality. And then with extraordinarily high network density, you're also not going to get any quality. And so we call that the plight of the crowd. In an extremely densely connected network, the spreading part dominates the filtering part, right? News spreads extraordinarily widely. You publish something, it goes everywhere, you get tons of eyeballs. Why should you bother producing quality? Okay? So in this intermediate area, the sort of this intermediate level of social connectedness is where you can have equilibria with high quality. What about if we add misinformation to this context? I told you we're hoping that we can get some notion, some way we can use this model for misinformation, to study misinformation. Misinformation can have this, we think, unexpected, we like unexpected stuff, right? Unexpected force that misinformation can actually lead producers to produce, the bona fide producers, they give them an incentive to produce high quality news. And essentially this is building on something, obviously, that follows from the first part, is that anything that sort of slows down the spread of this information gives producers, the bona fide producers, an incentive to produce high quality. Misinformation does that, right? And it does that through the filtering part of the consumers. Consumers are rational. They know there's misinformation. They're going to be more judicious about what they share, which is slowing down, which is sort of making the filter harder to get through, which is then slowing down the spread, which then feeds back into bona fide producers have a greater incentive to produce high quality. So that's the intuition. We'll obviously see the model. So I just said that. Consumers are more judicious about sharing news, which increases the revenues of high quality more than low quality stories for those producers. So what if we change the way producers earn revenue? So I've been having a revenue model where producers earn revenue from eyeballs on their stories. What if producers care about something else? What if they care about what consumers actually do with their stories? Right? And maybe we think there are producers out there who actually care about that. And if we looked at alternative models of revenues, we're going to see, obviously, we hope we will see different outcomes. So in this limit market, when I talk about limit market, I'm talking this extremely densely connected, so in the limit when everyone has infinitely many connections. Consumers, if through the filtering process of the consumers, through their sharing behavior, the consumers who see shared stories will be able to perfectly infer quality, it's just a law of large numbers, so that producers would have the incentive to produce high quality. So if they know that consumers can perfectly infer which is a high quality story versus a low quality story, and producers care about what consumers do with the story, then producers will want to produce high quality news. So changing the incentives, this is a modeling exercise, right? So changing the incentives of the producers will have differential effect on the outcome of the market, of course, because producers have a different objective function. So then we can ask ourselves these questions: what are the actual motives of the producers? Is it eyeballs on the news, or do they actually care what people are doing with their news stories or not? And we can have that discussion, but this model will help us understand what the implications are of those different revenue sources. Okay, so I'm now again going to jump into the model, as I promised. So it's a three periods. It's not really periods. It's a timeline. You'll see. So in the very beginning, producers choose an unobservable quality level, high or low, and then they broadcast the stories. This choice of high or low gives something we're calling story veracity, this P0. P0 is our sort of primary, one of our primary objects that's going to take us through the model. P0 is the probability that any story which is produced is high quality. So you can think of it as the average quality. Okay. Consumers tune in to an exogenous fraction tau of broadcasts. They see a story with probability tau. Then the consumers get a private signal of the quality that's not perfect, and I'll just give you all the guts of that in a bit. So not a perfect signal, but they get a private signal of quality. And then they just update, and then they decide whether to share it or not. And I'll talk about consumers' motives to share or not in a bit. They decide to share or not their story. Then all of their neighbors then see the shared story. So a consumer shares it to all of their neighbors. Again, this is, you can see now starting to see the simplifications in the sharing process, right? The consumers share it to all of their neighbors. All of the neighbors see a story that a consumer has shared. These consumers are also, everyone's rational here. These consumers see which of their neighbors have shared their stories, and then also update, right? And they update as to whether the story is a high or low quality story, and then these consumers ultimately act or not on the stories that they've seen. What do the producers care about? In the first model, the main model I'll be presenting, what producers care about is eyeballs on the story. So this is VH and VL is the notation I'll be using for visibility. So the visibility of a high quality story or the visibility of a low quality story, just think of that as the number of consumers or the expectation of the number of consumers that will see a story. That feeds back to the producers. So producers are getting revenues from views, which then feeds back into their incentives to produce high or low quality. Okay. So that's the outline of the model. So the consumer's behavior and sharing behavior feeds back into producers' incentives to produce high or low quality stories, because high or low quality stories are going to be seen at different rates depending on the consumer's sharing behavior. Okay. There we go. Okay. So let's now then build each of these blocks. So each block of the model I'm now going to build, I'm going to fill in all of those squares. All right, so looking at information supply. First, let's take a look at producers and the cost of quality. So we're going to have a large number of producers. Each producer has a random cost to produce a high quality story, C. There's a distribution of these costs. We are going to have some intrinsically motivated producers. So we have some producers who produce high quality no matter, in some sense, no matter what they're. And we built these in for two reasons. You might be wondering why we have them. One is because we think there might be these producers out there. There are journalism schools, after all. And two, it actually helps us get rid of some unstable equilibria at zero. So there's both two reasons for doing that. So we have intrinsically motivated producers. Some assumptions that we make is that producers cannot commit to high quality. They can't raise up a sign and say, I promise, I'm going to do high quality and put me in jail if I don't, right? Quality is not directly observable to consumers, but we are going to have consumers being able to get a signal about whether the story is high or low quality, and that signal will be, well, I'll get to it. When I model the signals, I'll talk about that. Oh, and they're private signals. Okay. And again, P0 is this story veracity. It's the probability that it is any particular story is high quality. And so just to make sure we're fixed on what this P0 is, it's a consumer belief. So a consumer believes that any story is high quality with probability P0, right? And in equilibrium, it's going to match producers' choices. So I'll be flipping back and forth between P0 being a belief and P0 being an outcome of the producers, what the producers are doing, but in equilibrium, it has to be the same P0. Okay, so P0 is our equilibrium object here. Okay? All right, so that's the producer side. Right, producer side. What about the consumer side? We've got a bunch of consumers. They're linked in a directed network. We're going to make this extremely simple. We just have, it's going to be symmetric. Every consumer has D neighbors. That's it. Consumers tune in to news, and they see any story with probability tau. Okay, so in an extension of the model, tau is also going to be endogenous, but for most of the talk, probably the whole talk, but if we want to talk about it over lunch or something, tau is going to be the probability that a consumer sees any particular story. Consumers value high quality news. Consumers are risk neutral. Very black box, again, okay, now here's more simplifications. Extremely black box payoffs of what consumers care about. They only care about high quality news, and they value sharing high quality news. So we don't model why consumers want to share high quality news, and I know many of us here have worked on that, but they just want to share high quality news. And we just, again, just put in parameters for that. They want to act only on high quality news. And so therefore there will be a threshold belief for sharing a piece of news or acting on a piece of news, which is just this ratio here. And then we make our lives even simpler and say, let's make that a half. Okay? So now, as I go on, I will be saying that a consumer wants to share a piece of news if it's more likely to be high quality than low quality. Okay? Of course, one can do comparative statics on all of this, but again, that's not our primary purpose. Okay? Not that it's not interesting, it's just not what we're focusing on right now. Okay, so what about the private signals, which I said that consumers are going to get? So a consumer sees a story, receives a private signal, our current notation, H or L. So there's a signal that it's a high-quality story, or there's a signal that it's a low-quality story. These signals have information, but they're not perfect. So if a story is high quality, the signal is H with this probability rho, which is bigger than a half, but it's not equal to 1. If a story is low quality, the signal is L, which is bigger than a half, but not equal to 1. So you get a signal which gives you an indication, it's right, that a story is high or low quality, and it's in the direction of what the story actually is, but it's not perfect. Okay? So the filtering isn't perfect. This rho is a random variable with its own distribution function, and the words we attach to that is the signal precision. If rho were 1, the signal would be perfectly precise. So there's a signal precision rho. Okay, so the realization of the signal and the precision of the signal is private information of any consumer, but everybody knows the model, right? All of the underlying features, the distributions, et cetera, are common knowledge, so that any consumer can update based on the information they've received. So this is just some notation for Bayes' rule. It's not even notation, just pointing out that as a consumer, I see a story, I get my signal, I update, I get a posterior distribution, that's going to be P1, my posterior, right? And then I decide to share or not given my posterior. And I'm going to share if my posterior is bigger than a half. Okay? Then the consumers in the next round who see me shared, they can update too, because they've got a number of consumers from whom they're seeing whether a story has been shared, and they can then update as well, knowing, or, again, everyone knows the underlying distributions, and they know that consumers are acting rationally and so on, can update and decide whether to act or not on the story. The act or not on the story sort of becomes very relevant if producers care about consumers' actions, but I'm just pointing out that that's what happens as we go along. Oh, I don't know where my little people showed up. Okay, this is not the way the slide is supposed to look. Let me just see where, okay, so so that little HL row is supposed to be near that guy over there, this person here. That's supposed to be a person, and that's supposed to be there. I don't know how they migrated. They looked good when I was looking at it in the lobby outside. Okay, so here we've got a connected network, and we've got some news producers just to fix what happens in our model. The producers, again, this P0 is a belief, but it's producers' actions and an equilibrium, they're the same. So consumers are going to be tuning into the broadcast. They see a piece of news with some probability tau. Let's take a look at our consumer up here on the left side. Let's suppose this consumer sees this piece of news. This consumer says, oh, what should I do? Should I share this with my neighbors or not? This consumer, so that is showing up there. So this person seems to have disappeared. There's supposed to be a person there. This person, gets a signal H. This person then updates, right? And then decides whether or not to share it with her neighbors. And that would have been a person. So she would have shared it with these people. And that's it. That's our diffusion process, so we stop. Okay, so again, the diffusion processes are wonderful. They're very, very interesting to study, but we've cut it off right here. Yes?
Do consumers know which news sources they're seeing things from?
No, so there's no, that should have been among my list of, there's no names attached to these. So in our basic model here, what we have, it wouldn't really matter, but if one imagined a repeated game of some sort, which again happens, you can imagine a news provider establishing a reputation for quality news provision. That would be built on top of this model. So again, this is the basic models, and then what helps in our news in our news markets might be things like reputation and so on. We can get to that. I've got a list of things that can help us out here in the conclusion. All right. So does everyone understand how the news diffuses and then we stop after one round? And so we see the filtering and again the spreading.
So just a clarifying question on the ordering. So is that now there's a red arrow going down to the second person? Is this second person now
No.
seeing what was shared and they're consuming that news story? Or
Yeah. This consumer here sees the piece of news.
So it's not that all of these guys get the information from the...
This guy could have gotten it from here too. So you can both have seen the story yourself and having seen that shared. So you could both have seen the story yourself and 10 of your neighbors shared it with you, and you will include all of that information that you have, both that you saw it, you got your own private signal, that somebody shared it with you, maybe 10 people out of 20, and you will use that information to create your posterior of whether or not you want to act on the story. Yeah. Okay. All right. So what we're looking for here is a symmetric Bayesian-Nash equilibrium, and our equilibrium object is this P0. It's the quality. So what consumers believe is going to be what producers actually do in equilibrium. So what I want to do now to construct and search for this equilibrium is construct the consumer's best reply and the producer's best reply. So what the consumers are doing is they're deciding whether or not to share based on P0, and then producers are going then to produce P0 based on consumer sharing. So that's where we're headed. All right, so let's take a look at consumer's best reply. So there's a P0 out there, that's their belief, and consumers are going to optimally share depending on their belief. So I've kind of previewed this. Consumer I sees a broadcast. They're going to share a story if their posterior belief, this P1, is greater than a half. Okay. So essentially, this way this works, you can probably you can read it right there, and you've probably already figured it out, that if the belief is bigger than a half, if a consumer thinks that a story is more likely to be high than low quality, then they have to receive, yes, right. They will share it unless they receive a signal of L that is sufficiently precise, enough to move them away from their prior, right? The same thing for if the consumer had an initial belief that the story was a low quality story, they're not going to share unless they get an H signal that's sufficiently precise. So you can use that machinery to generate probabilities that stories are shared. So this is just the notation, beta H and beta L, beta H and beta L, which you'll then see in some further slides. So, and it depends on what the initial belief is. Beta H is the probability a high quality story is shared. And beta L is the probability a consumer shares a low quality story. And it's pretty obvious that a high quality story is more likely to be shared than a low quality story. That's the first bit there. And the overall likelihood of any story being shared is increasing in veracity, right? What's going to give us a lot of mileage is that there's this differential impact of P0 on the sharing of high and low quality stories as the veracity gets very high. Because as the veracity gets very high, the impact of this increased veracity on high quality sharing of high quality stories is going to be smaller than that for low quality stories. And it's that difference that we're going to see a few times in the model. And it's all just coming from the updating process and from this up here. Okay, excellent. So, okay, so that's the consumer's best reply to a given P0. Now, what about producers? Producers are deciding what to do given consumer sharing and filtering and sharing behavior. So producers are earning revenue from the fraction of stories who view, from the fraction of consumers who view their story. So what is the probability a consumer views a story? It's just 1 minus the probability that the consumer doesn't view the story. So it's the 1 minus the probability that a consumer misses the broadcast and no neighbor shares, which is just these formulas here. So VH is the probability that a consumer sees a high quality story. So this bit here is the probability that no neighbor of a consumer, remember, consumers have D neighbors, that no neighbors has shared that story. And this here is the probability that a consumer sees a low quality story, right? Again, very straightforward. And what gives the producer the incentive to produce high quality is the difference between VH and VL. So we're calling that the extra probability or the bonus from producing high quality, and it's just this increase in eyeballs, right? Increase in expected eyeballs of producing, increase in of high quality, let me start again. High quality stories are viewed with a higher probability than low quality stories are being viewed in expectation, and that difference is what gives the producers the incentive to produce that high quality story. Okay. All right. So a supplier is going to produce high quality whenever their cost of producing high quality is below that bonus, which gives us high quality supply, right? Whenever producers have that cost that's sufficiently low. All right, so now let's get into a characterization of supply. Clearly, high quality supply is 0 when consumers believe that no piece of news is high quality because nobody will pass it on, and so producers won't produce high quality. We can go to the opposite extreme. High quality supply is also 0 when consumers believe that every story is high quality. Consumers believe that every story is high quality, then they pass on everything, in which case a producer's best reply is to produce low quality because consumers are just going to pass it on, right? So this, by the way, that last bit is a, we used to have it as a little bit of a result, is that we need some low quality stories to be circulating in any equilibrium, right? Because if consumers are just passing on everything, then a producer's best reply would be to produce low, right? And so that would violate the idea that we could have a high quality equilibrium. So this producer's supply then is single peaked in P0. And it's also strictly decreasing for P0 greater than 1/2. And that's from that bit that I explained to you earlier on. Okay? So that's our characterization about the differential impact of P0 going up on the rate at which consumers are sharing high quality stories versus low quality stories. So that's producers' optimal supply for, as reaction to consumers' behavior. All right, so now let's put them together. So an equilibrium exists for any given D, and the pictures I'm going to draw for you is that D is sufficiently high that we've got this operation going all together. If D is 0 and D is 1, we might not be getting anything going on, right? Okay. So I'm looking for a P0. So P0 has to be bigger than, we know that P0 has to be bigger than this. This is the intrinsically motivated folks, and this 1 with the open bracket there is because we can't have P0 equal 1. I already told you that, right? Well, then it would just be low quality would be the equilibrium. We just have a dot in my picture. Okay, so what I've got here on my x-axis is P0, and on my y-axis I have the high quality supply. And this shape here is coming from the lemma that I had previously. It goes up and then it goes down, so there's a peak at P0. There's a peak, there is a P0 where it has a peak, so right here. And then we take a look at the 45-degree line, and that gives us our equilibrium. And this is where consumers' beliefs match the supply. And we have an equilibrium in our information market. So what consumers believe is what producers actually produce. So that's the construction of the equilibrium. And we now are going to use this equilibrium to do some exercises. One of the thing that started us out on this whole project was, what is the impact of increasing consumer connectedness on the information market, right? When consumers become more and more and more and more connected, which is, of course, the trend that we see and that people worry about a lot, what is the impact on information quality? So, I'm jumping ahead of myself. So my comparative static is going to be on D. I'm going to have D get higher and higher and higher and see what happens to our equilibrium. I can probably skip this slide, but one of the things that you might know is that we're going to focus on what this maximal veracity equilibrium. The reason I kind of forgot about it is that we're always over here on the side of bigger than a half. So we're not really over here. We're really in this world where we're on the downside of this high supply curve. That's why I kind of forgot what I was doing. And, but there are possibly multiple equilibria on the way up to that peak, but not on the way down. And because on the way down, we're bigger than a half. All right, so let me give us some preliminaries about D. And this is kind of the guts of what's going to of the main result. There's a non-monotonic effect of D, I previewed this in my very first preview slide, on the visibility of these stories. So let me just say it in words before I put it up there. So if we have D being very small, this is the spread of information, right? If D is very small, not a lot of information spreads. You increase D by a little bit, then which kinds of stories are going to benefit most from that? It's going to be the higher quality stories than the lower quality stories, right? Because the consumers are they're the ones that get through the consumer filter at a greater rate. Okay. But then as D gets really, really big, and then go to the other extreme, D is huge, right? Then any story which gets through the filter spreads extremely widely, so the benefit of producing to the producers. The benefit to the producers of producing high quality rather than low quality shrinks to zero. Okay? And now I'm just going to show you the pictures and the math that goes behind that. All right, so delta V, remember delta V is the extra eyeballs on high quality stories. So I'm going to look at the impact of increasing density on these extra eyeballs. So therefore on consumers and producers' incentives for producing high quality. So I just have up here the equations for VH and VL, again, just to remind you. And then I just have a little thing here where I forget the number, D, 0 to 10. I forget exactly the numbers I had in there for tau. It's a tiny little simulation to show you the shape of these things. So when we're at low density, so we're down here, and we increase D, right? The number of eyeballs on this high quality story is increasing faster than the number of eyeballs on a low quality story, right? But then as so the difference between the two is increasing. High quality news is shared marginally more often than low quality news. Okay. But as we get towards this range over here, we can see that the eyeballs on the low quality stories is increasing faster than the eyeballs on high quality stories, which makes the difference, this delta V term, start to shrink and eventually goes to 0. And again, when D is extremely high, even though low quality stories is viewed widely, so the producer in the end has less incentive to produce low quality news. That delta V shrinks to 0. So this is the lemma that comes from that argument. So delta V is single peaked in D, and in the limit, it's 0. Where am I going? Okay. So this is one of our main propositions. So we're thinking about this maximal equilibrium and the connectedness level D. So first, either we're below a half for all D, but if we're above a half in terms of P0, if P0 is above a half, then there exist these threshold Ds, right? So that if D is in the middle range, we have high quality being produced. But if D above that D, then above that threshold, I guess it's our D over bar, right? Then high quality is not being produced. And this is, again, just coming from the lemma. And here's a picture of it. It's basically the picture I showed you before. We need to be in this region here, right, to have this, we need to be in this region to have our high quality equilibrium to be greater than 0, greater than 0. So, this picture is illustrating a case where D is in this intermediate range. And it's the picture you saw before. Okay, if D were not in this intermediate range, we'd be at a dot. And this is just following from what I was just telling you before. If we have D get infinitely large, then the delta V term shrinks to 0, and we have only low-quality news being produced. And we call this the plight of the crowd, to be dramatic. Okay? As opposed to the wisdom of the crowd. I think you get the idea. Right? But I think that calling it the plight of the crowd, though, we're not only doing it to be dramatic because we like to write, like to highlight things when we write, but I think it also highlights, if we want to get out of this trap, what do we need to do, right? So anything that sort of gets us out of this plight of the crowd should hopefully push us more, or the model would tell us, would push us more towards higher quality, right? So in this model, it's very dire, right? If all the producers care about is eyeballs on their stories, and if consumers are hyper-connected, then we're going to get low-quality news, right? So then we start thinking, well, okay, so how do we interrupt that process? What are the places where that can be interrupted? You might know there are some policies out there. I think, in the paper we write about, Facebook has a policy about limiting the number of people to whom you can spread a piece of news, or the groups that can be you can access through these sharing models. So you've sort of, some of you nodding, you've sort of seen these ideas out there. Well, that would be one of these ideas, that you somehow want to put brakes on this process. Okay, so let me give you a sense of what we do with this model. One of the things we were also that motivated us to work on this problem are these misinformation agents. Of course, we're all extremely, I think many of us are trying to understand the phenomena of misinformation, right? And my gosh, there's a huge, we all spend our lifetimes trying to understand this. So we're trying to think about how misinformation agents, and we're literally thinking about foreign governments possibly, putting out false news stories, which happens. How does that impact our information market here? So we're going to consider M misinformation agents. Wow, misinformation agents of misinformation agents. Okay, so that shouldn't be there. Alongside S bona fide suppliers. Okay, so we've got M misinformation agents, and we've got our regular old S bona fide suppliers. And we have this measure of how much misinformation there is in the market. So the total quantity of news is now S plus M. And the way we model our misinformation agents is that misinformation agents are always producing low quality. So I'm not modeling, which would be amazing to do, I'm not modeling the motives of our misinformation agents, which would be super cool, right? And we can talk about that later. But our misinformations are just dumping low quality news into our market. They're not strategic actors here. So this is just some notation. So the share of news that's high quality is the supply of high quality from our bona fide producers over 1 plus M. Okay? So we have a modified notion of news veracity here. So if the level of high-quality news being produced by our bona fide producers was fixed, misinformation is always bad, right? You dump misinformation in there, you have a fixed behavior on the part of our information providers, the ones that have these incentives. Misinformation is always terrible. But, as I've been emphasizing, the high-quality news production here is not fixed. The producers are going to be doing something here. They're not just going to sit there and just have a fixed supply. They have incentives. The producers of this information also have incentives. And again, that's the whole purpose of, one of the whole purposes of the paper is to think about, again, what diffuses through a network. That person who's producing something that diffuses through the network itself has incentives. And so we want to look at that as being an endogenous process. So what is the impact of of misinformation on the high quality production? And here's the somewhat, we think, surprising result is that if the misinformation which is being introduced is there, but not huge, then it can actually lead to incentives for the high-quality producers to lead to greater incentives for the bona fide producers to produce high quality. Okay. Let me state this and we can go through the intuition, and I'll show you a picture. Clearly, if there's so much misinformation that it completely swamps the market, and the consumers have this belief that there's so much information out there they can't believe anything or everything's low quality, then our bona fide producers are also going to be producing low quality, and it's only our intrinsically motivated producers who are going to be doing high quality. Okay, that's there. That's definitely there. Enough misinformation could destroy our information market. But if we started out at a relatively functional information market, so P0 was bigger than this half, right? So the news was more likely to be high quality than not. And we put in a little bit of misinformation, the bona fide producer's response, again, through the consumer's behavior, because the consumers are going to be changing their sharing behavior, is to produce more quality production. And consumers can actually be better off if the elasticity of this supply is high enough. Okay, so the intuition is, I think I've said to you about several times, is basically the consumers are then not sharing as often, right? And that's going to benefit delta V rather than delta L, relative to delta L. Deltas, right? It's kind of warm up here with the lights. And the producers then, the bona fide producers, will have a greater incentive to produce high quality. So here's the picture. So we're starting out at an equilibrium where P0 is greater than a half, so we're over here on the right. And so we're starting out here where there's no misinformation. Now let's add a little bit of misinformation. When we add a little bit of misinformation, it's essentially shifting consumers' beliefs up from this 45-degree line. Right? Consumers know that there's misinformation. They're taking that into account. So we shift that up. And then here is where we will be on the producers, the bona fide producers' supply curve. So the bona fide producers can have an incentive to produce quality. And if I've got it right, I've got our new equilibrium. Okay, so in our new equilibrium, we have misinformation, but we also have the producers endogenously compensating isn't quite the word. That's not what they're doing. They're just profit maximizing, right? Because consumers are sharing less often, then remember it's a brake. It's a brake on that plight of the crowd kind of force. So then producers will have an incentive to produce, higher incentive to produce higher quality. Okay, so let me step back a second and ask, yes? Yes, I wouldn't use the word dynamic because this is a static model, but essentially yes. So consumers know there's an M. Consumers know what M is.
So it's just like, this is like first degree, like, oh, if you know, consistently we're producing our.
Right, except again, I wouldn't use any dynamics here. It's just that consumers know there's M, they know the quantity of misinformation in the market, then that changes their expectation if they encounter a piece of news as to whether it's high or low quality. And then I look for an equilibrium. So changes, I probably shouldn't have used that word, but this is our, whoops, we ultimately have an equilibrium here, where consumers have adjusted their, I telling you not to use the word dynamic, and then I keep using those words. In equilibrium, consumers have a new belief that incorporates the fact that there's M misinformation providers, and the news providers have a new level of high versus low quality information, and we have a new equilibrium. So but we do not model an adjustment process. Okay, we're just in an equilibrium where we've got an M in there. And we can do comparative statics on M, which we do. Okay. Excellent. What I'd like to do is give one more bit of what we do, and then see if we have time for more questions. So I think I want to sort of step back from our model and take a look at the literature on media markets. And as you know, there's a lot of literature on media markets and a lot of literature on bias in the media. And as you notice, we don't have bias in our model at all, right? Consumers are just looking at high or low quality. They don't have a bias over the state of the world, et cetera. This is not the model that we have. It's not what we're examining. However, in this literature on media, there is this really interesting work on the impact of advertising. And remember, advertising is one of my examples as a source of revenue from producers, the advertising that accompanies a news story. So there's this really nice historical study about the American newspaper market, and think back to a time when newspapers were sponsored by trade unions or sponsored by political parties. So literally the newspaper was the newspaper of the trade union. And there was an innovation where newspapers, instead of relying on the trade union for support, were able to get an ad from Macy's, right? So, or whatever. So the model, the media market transitioned from direct support of newspapers to advertising-supported newspapers. And this wonderful work by these wonderful authors showed that reduced the bias in the news because the newspapers no longer had to rely on their sponsors for revenue. In our connected world, I've just built a model which shows that this advertising revenue can be really bad for news quality. Again, I don't have bias, I have quality. If producers only care about revenue that's, say, based on advertising, because advertising is eyeballs on the news, eyeballs on a story, then we have our possibility in a very, very connected world that as consumers become more and more connected, stories travel very widely and there's no incentive for quality. So it's we have to be cautious, again, about where the revenue, we have to be cautious, it's a market, right? So they're getting revenue from advertisers, and this is an implication. Our model's giving an implication of that. So what if we changed our model of revenue? What if we said that producers are not getting revenue from the advertising revenue, from the advertisers that is accompanying their stories, but maybe producers care about what consumers do with their news? So I don't really have time to go through this because I want to leave a bit of time for questions. Basically, I'm just going to have the same model, but I'm now, instead of consumers seeing and shared stories, updating and acting or not, the revenue flow that goes to producers is not coming from here, but it's coming from their actions and then feeds back to producers, right? And then in the limit market, I'm just going to talk us through it. I'm just going to get to my conclusion slide real quick, and I'm just going to talk us through. Okay, before I get to that, I just want to talk us through the revenues from actions. So if producers care what consumers do with the story, and remember, consumers want to act on high quality. They don't want to act on low quality. Now put us in the limit market where everyone's got infinitely many infinitely many neighbors. Then consumers can perfectly infer from sharing behavior, from their neighbor sharing behavior, whether a story is high or low quality. It's just the law of large numbers. So I have 100, well, I have a million, whatever. I don't have 100, because I'm in the limit case. 1/3 of my neighbors share. 2/3 don't share. I know then I can infer the quality, right? And if producers care about whether or not I act, and I'm only going to act on high quality, then producers have incentives to produce high quality in that case. Okay, so we can completely overturn the results of the revenue from views model. So let me summarize. What have I done? We have a simple model of the market for news. Consumers are rational and producers are profit maximizing. Equilibria exists with high quality news, but low quality needs to circulate. We have this non-monotonic effect of D on high quality news production. Misinformation can perhaps surprisingly lead to an increase in high quality production. Revenues from consumers' actions can improve quality. And then I have an extension I didn't have time to talk about. Further research, endogenous network links. I'm just going to flash them. Industrial organization of producers, right? We have subscription models. We have competition among producers and so on. And this is my favorite. Very hard to even think about a multidimensional news product, right? So people share news not just because they think it's high or low quality, because it's surprising, it's funny, it's shocking. How might that interact with consumer sharing behavior? But then also, because ultimately in the end, if producers are only acting on news which is high quality, how do we understand that process? So thanks very much, and I'm happy in the maybe 1 minute, 2 minutes for questions, and then I'm happy to talk over lunch and so on.
We can take a quick question or two. Please.
We have a question from the chat here. Some apps or social media apps have a reward for inviting friends to join the app or social media network, essentially decreasing the filter for sharing at some cost for the producers. Can we get some inference on the effect of such programs on the equilibrium from the model?
So I think I missed some of those details, but I think the answer should be yes, because I didn't hear anything in that was outside of the model. So, but I think the questions kind of combined filtering and spreading in the question. So basically, the more and more consumers that share, that consumer can share their information to. So D here, we have this non-monotonic effect of the consumer connectedness, right? And if we're subsidizing D, which is kind of like the links, if we're making D extraordinarily cheap, we're verging into the territory of D very, very high, right? Where if D is very, very high, that is reducing producers' incentives to produce high quality, because you can produce anything and it will spread. And there are cases of that. There are people that basically earn this Denver Guardian earned, it was not a news source. It was just a website that had fake news on it and earned advertising revenue. So I'm not sure if I answered every little bit of that question, but that would be the trend.
Take one more. I think, please. Yeah, go ahead.
Oh, great, okay. So I was going to ask you, do you have a notion of social welfare in this setting? Like, is that just, say, the total number of consumer eyeballs that see high-quality news? And if so, how does that relate to, like, the deep connectedness?
Right. So it's a good question. And the answer is no, we kind of shied away from that. But I can give you the misinformation story. We had some notion in there about consumer welfare. So what's happening there is that the average quality falls, but consumers see more information, even though it has a lower average quality. And consumers can be better off in that circumstance, right? Because they're seeing more. Imagine that the quality falls just a tiny bit, but there's many, many more stories. So we do an exercise in the misinformation case, but we don't overall balance producers, consumers, and understand the trade-offs between producers and consumers and have a weighted welfare function. We took a look at consumers being well off, and our measure of that is how many stories do they see of a particular quality.
Okay, there are many more, but I fear we better wrap it up here. I invite some of you to come forward and ask Rachel more questions offline, some of you to go to lunch, and all of you to thank Rachel
Well, thank
for this
you.
time.